Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So in previous sessions, we have discussed about engineering typology subject. So in this subject, we have studied various modules like friction and wear and lubrication and corrosion and engineering materials. And also we have seen some important questions discussion related to the engineering typology topics. Today, in this session, I want to explain about engineering materials part 2. So, part 1 in already we have learned many materials. So, this is like revision of engineering materials. So, already once we have discussed in earlier. So, once again you will see. So, what do you mean by engineering materials, and what are the importance? What is the importance of engineering materials in engineering typology, and how many types of materials are there, and what are the advantages and the disadvantages, and applications of various materials? We will see in this session. First of all, the introduction about engineering materials. So, engineering materials are the fundamental substances used in the construction, manufacturing of various products and structures. So, fundamental substances, these engineering materials. So, everywhere in our daily life, we are using many materials for construction purpose and manufacturing sector. They are used many materials: plastic, steel, ceramics. So, many materials are there for to prepare various products and structures. So these are the fundamental substances for any manufacturing of a product. These materials are selected based on their properties and their suitability for specific applications. So these materials selection is important. That is based on their properties and suitability for specific applications. So, which material is suitable for proper application? Ranging from everyday objects to complex industrial components. So that before selection of material, the every engineer should know about their properties of different materials, and also feasibility of particular material for specific application. The material withstand the strength or not, and is it machinability or is it weldability. So these all are design consultations, so manufacturing applications. So the field of engineering materials encompasses a wide range of substances, including metals, polymers, ceramics, composites, and semiconductors. This engineering field, in the field of engineering materials, including metals and polymers and ceramics, composites, and semiconductors, conducting materials, electrical conductivity materials, thermal conductors. So many are there in engineering field. We are using for manufacturing of various products. So in this, the important materials we will see the aluminum alloys. So classification and other properties of engineering materials we have studied in a regular theory class. So in this, so I will touch some important materials. So aluminum alloys. So these alloys are known for their excellent corrosion resistance. So these materials having high corrosion resistance. So it can withstand the corrosion, and also it can withstand high temperature strength, and often their ability to maintain these properties across a wide range of temperatures. So these material you can use at elevated temperatures. Why? Because having that much of strength, high temperature strength. So if you left this material in environmental open environmental conditions, it will not affect due to weather. So why? Because they having these aluminum alloys having excellent corrosion resistance. So corrosion means rust formation will be occurred on the surface of the metal. Whenever this material surface exposed to environmental conditions. Composition. So aluminum alloys typically contain aluminum as the base metal. So in this, in any alloy, one base metal is there, and then additionally other materials will be added to enhance the properties. Then only will get more strength and other resistance properties. Here also see the composition, the aluminum alloys contain aluminum as the base metal along with other elements such as copper, magnesium, silicon, manganese, and zinc. These alloying elements are added to enhance specific properties. Already I told you. So these alloying elements added to the base metal. Why? Because to get the required properties, desired properties. So what are the elements added in aluminum alloys? The base metal is aluminum. Other materials are copper, magnesium, silicon, and manganese and zinc. So these are the other alloy elements. In this, two types are there. One is wrought alloys and cast alloys. So aluminum alloys can be broadly classified into two categories. So wrought alloys, these are produced by mechanical work. So mechanical work means rolling, extrusion and forging, welding and machining. All these are mechanical manufacturing process and are used in applications where strength and ductility are important. Cast alloys, these are produced by casting methods and are used when shaping flexibility and design freedom are prioritized. The casting methods are used when shaping flexibility So whenever required the flexibility, the shape flexibility, you can mold into any shape. That process is called casting process. Next, properties. So what are the important properties of aluminum alloys? One is lightweight. So aluminum alloys have a low density, making them ideal for applications where weight reduction is critical. So example, aerospace, automotive. In automotive and aerospace components like landing gear and engine components, exhaust systems in aerospace and automotive, there weight reduction is important so that in those places this lightweight material aluminum alloys are used and also having these materials low density. Next, one more property is corrosion resistance. So the aluminum naturally forms a protective oxide layer which enhances its resistance to corrosion. So whenever occurred any layer on a metal surface, it leads to enhance the resistance to corrosion. So that's why in corrosion also you are using some protective coating methods to control the corrosion or to avoid the corrosion. Here, the material itself, the aluminum, naturally forms a protective oxide layer. Next, electrical and thermal conductivity. Aluminum is a good conductor of both electricity and heat, making it suitable for electrical transmission lines, heat exchangers, and other applications. It is a good conductor of both electricity and heat, so electrical transmission lines and heat exchangers, and for other applications also used this aluminum alloy material. Why? Because having good electrical and thermal conductivity properties. It is a good conductor. Machinability. So aluminum alloys can be easily machined, formed, and welded, contributing to their versatility in manufacturing. So good weldability, good machinability, and good formability. So and then easily machined, turning and step turning or facing any operation you can do easily. So they're having that property, machinability property. Just aluminum alloys applications. The applications are find extensive use in various industries, including transportation, automotive bodies, aircraft structures, and marine applications. And the construction side, window frames, scaffolding, structural components, and packaging, cans for beverages and food carrying equipment, aluminum alloys are used due to its low density property, lightweight, and resistance to corrosion. And electronics equipments, heat sinks, electrical transmission lines are used aluminum alloys. The consumer goods, cookware, furniture, appliances. Next advantages are aluminum alloys advantages: high strength to weight ratio, excellent formability and machinability, recyclability. So recyclability, aluminum alloys are highly recyclable, and is saving energy and resources. So having advantage, high strength to weight and excellent formability and machinability. Next challenges, higher initial cost compared to some other materials. So like steel, susceptibility to galvanic corrosion in certain environments. Specific alloy compositions are required for different applications, which may require careful selection based on performance requirements. So these are the challenges of aluminum alloy material. So when compared to the other materials like steel, the initial cost is very high. That is the more challenging one. So susceptibility in galvanic corrosion in certain environments. This one also uh, very important challenge. The other compositions are required for different applications, which may require careful selection based on performance requirements. Next, aluminum alloys. Brief summary is aluminum alloys are versatile materials with a wide range of applications across industries, prized for their combination of lightweight strength, corrosion resistance, and ease of processing. So their continued development and adaptation to new technologies and applications make them indispensable in modern manufacturing and engineering areas. So this is the brief summary about aluminum alloys. So wide range of applications in across industries and a combination of lightweight strength and corrosion resistance and easy of processing in modern manufacturing and engineering sector, very useful material. Next, nickel based alloys. This one also alloy material, but in this material, the base material is nickel. So the nickel based alloys are a class of metallic materials that primarily consist of nickel as the base element, with other alloying elements added to enhance specific properties. These alloys are known for their excellent corrosion resistance, high temperature strength, and often their ability to maintain these properties across a wide range of temperatures. So mainly these alloys, nickel based alloys also having excellent corrosion resistance and a high temperature strength. It can work at elevated temperatures like aluminum alloys. So other materials added to this nickel based alloys to enhance the specific properties. So what are the other elements? We will see here composition. So nickel based alloys typically contain significant amounts of nickel, often more than 50%, along with chromium, molybdenum, iron, cobalt, and other elements like titanium, aluminum, and tungsten. These alloying elements contribute to the alloy specific properties. So nickel based alloys typically contain significant amounts of nickel. So what are the other elements? One is chromium, molybdenum, iron, cobalt. Other elements like titanium, aluminum, tungsten also will be added to this nickel base metal. So to improve the specific properties. So what are the properties? Now we will see here. Corrosion resistance. Nickel based alloys are highly resistant to corrosion, particularly in aggressive environments, including seawater, acids, and alkaline solutions. So high temperature strength. They retain their mechanical properties at elevated temperatures. So making them suitable for applications where high strength at high temperatures is required. Wherever required, high temperature and wherever available those conditions, high temperature. Suppose any component machine is working at elevated temperatures and require more strength, there this material is very useful, nickel based alloys. So such as gas turbines, aerospace components, and chemical processing plants. These are uh, properties of nickel based alloy. Another property is wear resistance. Some nickel based alloys exhibit excellent wear resistance, which is beneficial in applications involving friction and wear. Fabricability. So they can be fabricated into various forms such as sheets, blades, tubes, and wires. It means and can be easily welded or machined depending on the specific alloy composition. So the fabricability means so like machinability and weldability, the feasibility of fabrication. It can be easily welded or machined. So that is depending upon our alloying composition, which material you are alloying. Next, what are the applications? Aerospace applications used in jet engines, turbine blades, combustion chambers, and other components where high strength and corrosion resistance are critical. Jet engines and turbine blades and combustion chambers, all these are working at high temperatures and also high strength, and corrosion resistance also high resistance is required. Whereas in oil and gas company, the components for down wall, drilling tools, valves, and piping systems where resistance to corrosive environments and high temperatures is necessary. Other applications are chemical processing. Equipment such as reactors and vessels where resistance to corrosive chemicals and high temperatures is required. Electronics. Nickel alloys are also used in electronic components and batteries due to their electrical conductivity and resistance to corrosion. So that's why these alloy materials are used in electronic components like batteries due to their electrical conductivity and resistance to corrosion problem. Next, types of nickel based alloys. In the previous case, in aluminum alloys also we have seen two types aluminum alloys. Here, nickel based alloys also different types. One is inconel, a well known family of nickel chromium based superalloys, known for their oxidation resistance, high temperature strength, and corrosion resistance. So the inconel material, it's a family of nickel chromium based superalloys having oxidation resistance, high temperature strength, and corrosion resistance. As another series of nickel based alloys known for their expensive resistance to a wide variety of aggressive chemicals. The category is called Ashton. The overall summary of these nickel based alloys are crucial materials in industries where performance under demanding conditions is required, offering a balance of high strength, corrosion resistance, and thermal stability. So these are crucial materials in industries where performance under demanding conditions is required, so offering a balance of high strength, corrosion resistance, and thermal stability. Their versatility and reliability make them indispensable in modern engineering applications. So next, magnesium alloys. So these are metal alloys, but in this primarily the composed of a magnesium element, often combined with other elements to enhance the specific properties like aluminum alloys and nickel based alloys. So these alloys are also known for their lightweight property, excellent strength to weight ratio, and good machinability, having all these properties like aluminum alloy and nickel based alloys. But only thing is here the magnesium is the base metal and alloying elements also other materials will be added. That is depends upon strength requirement and other properties requirement. Depends upon application also. You can add other elements to this magnesium alloys to get the desired properties. Here shown some aspects of magnesium alloys. The composition consists of magnesium as the base metal with alloying elements such as aluminum, zinc, manganese, silicon, and rare earth elements like cerium and zirconium. These two are very rare materials, cerium and zirconium. These alloying elements are added to improve mechanical properties. What are the mechanical properties? Strength, hardness, brittleness, ductility, fatigue. So these are mechanical properties. So whenever added these elements, you will improve these properties. So corrosion resistance and other characteristics. What are the properties? Lightweight property and high strength. So the magnesium is one of the latest structural metals, making magnesium alloys highly attractive for applications where weight reduction is critical, such as in automotive and aerospace industries. So automotive one sector and aerospace industries are frequently used these materials. So because of in two industries, weight reduction is critical. Despite its low density, magnesium alloys can exhibit good strength, especially when alloyed with elements like aluminum or rare earth metals like shown here, cerium and zirconium. Other properties are good machinability. So magnesium alloys have excellent machinability, which allows for easy shaping, drilling, and milling, making them suitable for various manufacturing processes. The corrosion resistance. The magnesium alloys can offer good corrosion resistance depending on their alloy composition. Some alloys are specifically developed to enhance resistance to corrosion in different environments. So having good machinability and corrosion resistance. Next applications are in automotive and aerospace. These alloys are used in automotive applications to reduce the weight and improve the fuel efficiency. Whenever a weight reduced, so you will get a good improvement in fuel efficiency. They are used in components such as engine blocks, transmission cases, steering wheels, and interior parts. In aerospace, magnesium alloys are used for lightweight structural components, aircraft seats, and helicopter rotor blades. So, due to its lightweight property and high strength, and it can withstand at a high temperature. So, that's why used in aerospace sector. The other applications are consumer electronics and medical devices. So, the magnesium alloys are utilized in portable electronics like laptops and smartphones. Due to their lightweight and durable properties. So some medical devices and implants benefit from the biocompatibility. So compatibility with human tissues. So non-toxic and a lightweight nature of magnesium alloys. So the biocompatibility, due to this property, the materials are used in medical devices like bone replacements and dental implants. So why? Because this does not harm with the human tissues. Challenges are flammability. The pure magnesium and some magnesium alloys are highly flammable under certain conditions which can force safety concerns. So safety concerns are very important. And corrosion, some magnesium alloys can be susceptible to corrosion, particularly in environments with high humidity or exposure to salt water. So whenever this material is exposed to salt water, there must be corrosion. So this is very challenging parts. These two are related to this magnesium alloy, flammability and corrosion. Next, types of magnesium alloys: AZ series and W series. These includes alloys such as AZ31, AZ61, and AZ91, where the numbers denote the percentage of aluminum and zinc added. So W series is, these are magnesium rare earth alloys which include elements like yttrium, cerium and zirconium. So the very rare earth elements to improve strength and corrosion resistance. So the overall summary of the magnesium alloys offer significant advantage in terms of weight reduction and strength, making them valuable materials in industries where lightweight and high performance materials are required. The advances in alloy development continue to expand their applications across various sectors, though considerations regarding corrosion resistance and flammability remain important in their use. So these are the overall summary of magnesium alloys. So another important materials alloys is titanium alloy. So in this titanium alloys, the types of titanium alloys are: one is commercially pure titanium. So already we have graded like 1, 2, 3, 4. The composition is essentially pure titanium with minor amounts of oxygen and iron. Alpha alloys grades: Ti 5 aluminum, 2.5 tin, titanium, and titanium with 8 aluminum, 1 molybdenum and vanadium, and titanium 6% of Al, aluminum and 2 tin, 4 zirconium and 2 molybdenum. The composition is primarily aluminum and tin with the traces of other elements like molybdenum and zirconium. Next, alpha beta alloys grades are titanium 6% of aluminum and 4 vanadium. Similarly, titanium 6 aluminum, 6 vanadium, 2 tin, titanium 6 aluminum, 2 tin, 4 zirconium and 6 molybdenum. The composition is a mixture of alpha and beta stabilizers like aluminum, vanadium, tin, zirconium and molybdenum. These are the composition of alpha beta alloys. So the beta alloys, the grades are titanium 10 vanadium, 2 ferrous, 3 aluminum. Similarly, Ti 3Al, 8V6 chromium, 4 molybdenum, 4 zirconium. So titanium is the base metal and other alloying elements are vanadium, molybdenum, zirconium, chromium to enhance the properties. The composition contains a higher amounts of beta stabilizers like vanadium, chromium, molybdenum, and zirconium. So advantages of titanium alloys are: one is high strength to weight ratio. So titanium alloys have excellent strength while being significantly lighter than steel. And corrosion resistance. High resistance to corrosion in various environments, including sea, water, and acidic conditions. So whenever this titanium alloy material exposed to seawater and acidic conditions, whenever exposed to various environmental conditions, having a good resistance, high resistance to these corrosion and acidic conditions. So biocompatibility, non-toxic and compatible with human tissues. So making them ideal for medical implants like dental implants and bone replacements in orthopedic surgeries. So high melting point, capable of withstanding high temperatures, making them suitable for aerospace applications. And similarly, fatigue resistance. The fatigue resistance is superior fatigue strength compared to other metals, which is crucial for components subjected to cyclic loading. You know, the fatigue resistance means whenever the component is subjected to cyclic loading or repeated loads, the component will fail due to the yield stress after a certain number of cycles. This phenomenon is known as fatigue. So whenever the material having good strength withstand to this fatigue, the component will not fail and it gives good performance. So that's why this material having fatigue resistance, keep resistance, good resistance to creep at high temperatures. The fatigue, creep, conductivity, strength, all these are mechanical properties. So in nothing but this material having good resistance to mechanical properties, maintaining strength and stability under prolonged stress. If you keep on increasing the stress at high temperatures, it does not affect to the component. What are the applications of titanium alloy? Aerospace applications, already we have discussed, aircraft frames, jet engines, and space exploration vehicles due to their high strength and low weight. Medical applications, implants, prosthetics, surgical instruments because of their biocompatibility and non-toxic nature. Marine, submarine components like ship parts and offshore structures for their excellent corrosion resistance in seawater. And chemical processing equipment exposed to harsh chemicals such as heat exchangers and reactor vessels. Automotive. High performance automotive parts like exhaust systems and engine components. So that the titanium alloys are widely used in this aerospace and the medical sectors and marine and chemical processing and automotive due to its lightweight property and then having due to its more strength and high resistance to the corrosion and high resistance to elevated temperatures. In engine components, exhaust system are having more temperature, so that in this material, titanium material alloys are used in this automotive. Similarly, in marine aerospace also. Next, aerospace applications mean aircraft components. What are the aircraft components? Such as engine parts, airframes, landing gears, due to their high strength to weight ratio, corrosion resistance, and ability to withstand high temperatures. The titanium alloys are used in the manufacture of critical aircraft components. Spacecraft, their lightweight and strong properties like the structure and other components, spacecraft components, to make them ideal for these components. So medical applications, whereas implants and prosthetics, the titanium alloys are biocompatible, compatibility with the human tissues, meaning they are not harmful or toxic to living tissues, making them ideal for surgical implants like hip and knee replacements, dental implants, and prosthetic devices. So why? Because does not harmful and also are not toxic to the living tissues. Surgical instruments, these alloys are used to make surgical tools because they are non-magnetic and resist corrosion from bodily fluids. Next, industrial applications. Chemical processing equipment. Due to their excellent corrosion resistance, titanium alloys are used in chemical processing plants for tanks, heat exchangers, and piping systems. So, having excellent corrosion resistance, the power generation, they are used in components of power plants, including nuclear power plants, due to their ability to withstand high temperatures and corrosion. So, marine applications, marine hardware, that is, titanium alloys are used in the construction of ship hulls, propeller shafts, and other marine hardware because of their resistance to seawater corrosion. The offshore structures, they are also used in offshore oil and gas rigs for various structural components. These are the marine applications. So, whereas in automotive applications, high performance parts, titanium alloys are used in the manufacture of high performance automotive parts, so engine valves, connecting rods, and exhaust systems due to their strength, lightweight nature, and resistance to high temperature. So, high performance wherever required, like our automotive parts engines. In engine, having many parts like cylinder and engine valves and connecting rod, crankshaft, piston, and exhaust system mufflers. So here, a, all these subject parts components subjected to very high loads and subjected to high temperatures. So that this component material having the property high performance, high resistance property to temperature. Similarly, high strength. So next application is sports equipment, golf clubs, bicycles. So the lightweight and strong properties of titanium alloys making them ideal for high performance sports equipment including golf club, bicycle frames and tennis rackets. The consumer electronics, laptop and mobile devices. The titanium alloys are used in the casing of high-end laptops and mobile devices to provide strength and durability while keeping the weight low. The consumer electronics means regularly in our daily life you are using laptops and mobile devices. The casings are made with this material, titanium alloys. Why? Because the lightweight and also it gives good durability. Next, in case of jewelry, in jewelry and watches, the titanium aesthetic appeal. So look-wise having good appearance. Lightweight nature, and hypoallergenic properties make it a popular choice for jewelry and watchmaking. In watchmaking and jewelry sectors, these materials are used titanium materials. And next, alpha alloys. Composition. Alloying elements are alpha alloys typically contain elements like aluminum and oxygen, which stabilize the alpha phase. These alloys may also include small amounts of beta stabilizers like vanadium, molybdenum, and but not enough to form significant amounts of beta phase. So these are the composition of alpha alloys. So microstructure is predominantly alpha phase hexagonal closed packed crystal structure. So the crystal structures are FCC and BCC and HCC, But in this, the alpha under microscopic testing, you can observe the hexagonal closed packed structure. The stability, the alpha phase is stable at room temperature and up to relatively high temperature. Next, properties having good strength, generally lower than beta alloys, but can be improved with alloying and heat treatment. Ductility, high ductility and toughness compared to beta alloys. The corrosion resistance, excellent corrosion resistance, especially in oxidizing environments, having a good corrosion resistance. And also creep resistance, good resistance to creep at high temperatures. Next applications are high temperature applications due to good creep resistance. They are used in applications like jet engine components, aerospace and marine, used in airframes, landing gear, and marine applications where corrosion resistance is critical. In aerospace landing gear components and engine components like airframes. In marine applications, corrosion resistance is a very essential. Why? Because the components are frequently subjected to different environments and seawater conditions. The beta alloys. Composition is alloying element. The beta alloys are rich in elements like vanadium, molybdenum, niobium, and chromium, which stabilize the beta phase. The microstructure. The phase is predominantly beta phase, having this body-centered cubic structure. Whereas in previous case, alpha are an hexagonal centered cubic centered crystal structure. And stability, the beta phase is stable at high temperature but can transform to alpha or alpha beta phases at low temperatures. It can transform to a alpha or alpha beta phase at lower temperature. But in previous case, alpha phase is stable at room temperature and up to relatively high temperature. Next properties are strength, high strength compared to alpha and alpha beta noise, especially after heat treatment. So in this heat treatment, by using heat treatment, different treatment process are there, nitriding and carburizing, annealing, normalizing. After the heat treatment, you can enhance the properties of the material. Here also the beta alloys having good strength properties when compared to the alpha and alpha beta alloys. So ductility, lower ductility and toughness compared to alpha alloys. The corrosion resistance. The corrosion resistance, excellent corrosion resistance, that is good, but generally not as high as alpha alloys. Workability can be heat treated to achieve a wide range of mechanical properties. So these are the properties of beta alloys. Next applications, high strength applications. High strength to weight ratio is essential in aerospace and in aerospace fasteners and landing gear. The medical devices used in surgical implants and other medical devices due to good biocompatibility and strength. Mechanical properties are hardness. These the mechanical properties of ceramics. In this ceramics, the hardness, the mechanical properties of ceramics. Ceramics properties here given: hardness, brittleness, and strength. These are all are mechanical properties. So ceramics are generally very hard material, which makes them resistant to wear and abrasion. These properties by ceramics are often used in cutting tools and wear resistant coatings. So brittleness, ceramics tend to be brittle, meaning they can fracture or shatter under stress without significant plastic deformation. So this limits their use in applications where impact resistance is required. So the deformation, plastic deformation means the material having the plasticity property. So whenever the component is subjected to some metal load, it tend to be brittle. It means does not giving any indication of deformation. Suddenly it will fail. Then it can fracture. So that wherever impact resistance is required, these ceramics materials are used. Strength. Ceramics can exhibit high compressive strength but are often weaker in tension and shear. In tension, the material is weak, and in shear also weak. The strength of ceramics can vary significantly based on their composition and microstructure. Next, elasticity. Ceramics typically have a high modulus of elasticity property, and meaning they are often very stiff, do not deform easily under load. It cannot deform under load. So having that elasticity property. So it can, after removal of load, it can regain its original shape. That is the elasticity definition. So thermal properties: high melting point, thermal insulation, and thermal expansion. The most ceramics have high melting points, making them suitable for high temperature applications such as furnace linings and thermal barriers. Thermal insulation: many ceramics are excellent thermal insulators due to their low thermal conductivity. This makes them ideal for use in applications requiring thermal insulation such as heat shields and insulators. And also having the thermal expansion property. The ceramic generally have low coefficient of thermal expansion, meaning they do not expand or contract significantly with the temperature changes. This property helps prevent thermal shock. Next, electrical properties: electrical insulation, piezoelectricity, and semi-conducting properties. So many ceramics are good electrical insulators, making them useful in applications such as insulators in electronic and electrical devices. The piezoelectricity means the certain ceramics exhibit these properties, generating an electric charge in response to mechanical stress. Whenever you apply stress, how it responds. These ceramics are used in sensors, actuators, and transducers. Use this property. Because of the ceramics having this piezoelectricity property, that's why used in these sensors and actuators and transducers. Similarly, semiconducting properties. Some ceramics like silicon, carbide, and certain metal oxides can exhibit semiconducting properties and are used in electronic components. So, due to these semiconducting properties, these ceramics are used in electronic components. And chemical properties: corrosion resistance and inertness. Ceramics are generally highly resistant to corrosion and chemical attack. So even at high temperatures, this material not having does not affect any deformation and does not corrode. So this makes them ideal for use in chemically harsh environments such as chemical processing equipment and medical implants. So inertness: ceramics are often chemically inert, means they do not react easily with other materials. This property is important in applications where material stability is crucial, such as in biomedical implants and containers for radioactive materials. So there, the material stability is very important in biomedical implants and containers for radioactive materials. So that this material does not react with any other material. There is no reaction whenever mixed with this material. So that property is inertness property having these ceramics. Next, physical properties. Next, density and porosity. The density of ceramics can vary widely. Some ceramics are very dense and heavy, while other like formed ceramics and lightweight materials. The porosity: ceramics can be engineered to have varying degrees of porosity from fully dense to highly porous. The porous ceramics are used in applications such as filters and catalyst supports. The porous ceramics mainly used in these filters and catalyst supports. So varying degree of porosity property. So optical properties, transparency or opacity. So it means some ceramics like certain glasses and sapphire can be transparent, translucent. So it means useful in optical applications such as lenses and windows. Other ceramics are opaque and are used in applications where transparency is not required. Next, refractivity. So ceramics can have high refractive indices, which is beneficial in optical devices like lenses and prisms. So these materials have high refractive indices. Wherever required, the refractivity, like a prism and lenses, this property is used so that the ceramics are used in this refractivity and these used in these lenses and prisms and windows. So these are the topics we have discussed up to now. So various materials we have seen, and also various applications and properties of different materials we have studied in this session. So mainly whatever you cover in this, these materials are very important in engineering tribology related components, wherever the mechanical components are working at high temperatures and wherever working in salt water attack conditions and very harsh environments. The first material is discussed aluminum alloy. We have seen aluminum composition, alloy composition, and then types and properties and applications and advantages. And also we have learned challenges. So similarly, and second material is nickel based alloys. So in this material alloys also we have seen composition and then properties. We have studied properties and various properties we have studied and then applications and then types of nickel based alloys. So in aluminum alloys also we have seen types, and in this nickel based alloys also we have discussed different types of nickel based alloys. And then magnesium alloys. So composition and then properties and applications and challenges. For every material, composition, applications and properties and types and challenges and advantages are very important. The types of magnesium alloys here we have seen. Next, titanium alloys. Types of titanium alloys we have discussed, and the composition and then advantages of titanium alloys and applications of titanium alloys. Various applications we have studied: aerospace applications and medical applications and industrial applications and marine applications, automotive applications and jewelry application. Similar next alloy is alpha alloy. Composition and structure, properties, applications. The beta alloys, composition, alloying elements also we have seen, microstructure, phase and stability, and properties we have discussed about the alpha alloy and beta alloy properties and applications. And similarly, the ceramics properties and thermal properties and mechanical properties. In these mechanical properties, hardness and metalness and strength and elasticity. And thermal properties already we have discussed the melting point, insulation and expansion. And electrical properties, insulation, piezoelectricity, semiconducting properties. In chemical properties, corrosion resistance, inertness. In physical properties, density and porosity. So the optical properties of ceramics also we have seen. So refractivity and transparency and opacity. These are the important discussion related to this engineering materials in part 2. In part 1, we have discussed about materials classification and then what is the structure of materials and the materials uses in industries and what are the applications of various materials. All these things, composition, we have discussed in part 1. In this part 2, we added some more materials to this module, engineering materials. So for this preparing PPT, I have taken references these textbooks and online material also available. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.